All right, and welcome to 2D3, the video notes. Up until now in our questions about projectiles, we've only been doing vertical motion. So now we're going to add a horizontal motion, and we're just going to be launching things horizontally to begin with. So our first example is, what happens when we roll a marble off of a table? So I'll have to draw a little table here. So something like this on a stand, like that, and our marble is going to be rolling off the end of it here. I'll put them about 2 apart. So to begin with, when it's rolling, it's moving at a constant velocity like this. I think also I need to note which way my is positive in both the x direction and the y direction. So I'm going to say in the x direction, that one's positive, and I'm going to make downwards in this case positive for my y values. And these arrows here, this is all velocity in the x direction. Now what happens when it starts rolling off of the table? It's going to start falling downward. So it's still going to move 2 to the right every time, but now it's going to start accelerating downwards. So here I went 2 to the right, 1 down, 2 to the right, 2 down, 2 to the right, 3 down, and we start getting that parabola shape again. Now at each dot I'm going to put how fast it's moving horizontally, that's Vx, and how fast it's moving vertically. So the Vx is constant the entire time. So the arrows are always the same length. Now my Vy, however, and maybe I'll switch to green, here it's 0, here it's going down a little bit, down faster, and then here even faster. So those are the Vy. So the key here is that we are going to separate our x and our y motion, where our x motion is just going to be our constant velocity. So the only formula that we're going to use is v is equal to delta x over delta t, or some different way of rearranging that. And I'm also, instead of saying v, I'm going to say v in the x direction, while vertically it's constant acceleration, and so we can use the big 5 there. Alright, so in our question it says, how long is the marble in the air and how far away does the marble land? Well, I guess I need to make up some questions here. So how about I'm going to say that this marble, the table, is 1 meter up. And how fast is it going? Let's say to begin with, it's going at 2 meters per second. So if someone's rolling the marble off of the table, it's going at 2 meters per second. And if the table is 1 meter high, how long is it in the air? So in other words, what's the time? And the second question is, how far away does the marble land? So that is really about this distance here, which is delta x. So this one is delta x equals question mark. Okay, so we're going to do that same thing. We're going to separate our x and our y. So here I have some space here. So in my x, I have Vx equals delta x equals and delta t equals, and in my y column I'm going to have all my big 5 stuff. Vi, Vf, a equals, delta t equals, and delta y equals. So let's fill in all the stuff that we know. Well, vertically we know that it's always going to be accelerating at 10 meters per second squared, and in this question I said that the down is positive, so that would be a plus 10 meters per second squared. If the table is 1 meter tall, it's going to be starting here. This will be my initial, and this will be my final spot. So it will be going downwards, which is positive, so delta y is going to be equal to 1 meter. My initial vertical velocity, this vi here, is going to be 0. Just like over here, this has no downwards arrow. The vy is 0. And what I need to do is find out what my time is. Okay, now one thing you're going to notice is that the time is what ties the x and the y components together. So in this question I'm going to solve for delta t using all the y information, and whatever that number is I'm going to put over in the x side. Looking at the x side just for now, what do we know? We know that it was moving horizontally at 2 meters per second. Okay, so let's try this out. Let's look at our y information, and which equation does not have a VF in it? That would be equation number 1. So I'm going to start off with looking in the y direction. Equation number 1 is going to be delta y is equal to VI delta t plus 1/2 a delta t squared. Since the initial velocity is 0, that term just disappears altogether. So I get 1 is equal to 1/2 of 10 is equal to 5. So I'll say 5 delta t squared. Divide both sides by 5, and then square root both sides. My calculator will say the answer is something like 0.4472 seconds. And just a little pro tip here, try not to round. Just either keep it on the display or keep it in the memory, and so that you don't round off until the very end. So the first answer is going to be, what is this time? Maybe 0.45 seconds. And so I might round for my answer there, but if I need to reuse the number, then I'm going to keep all the digits. Okay, so now looking at the x side, now I know what time is. I know what the velocity is, so I can figure out what the delta x is. So if v is equal to delta x over delta t, if I'm solving for delta x, it's going to be delta x is equal to v times delta t. So it's really just multiplying that times 2. 0.447, whatever else in the calculator. And so my final answer is 0.89 meters. And so there's my 2 answers. Okay, hopefully that was helpful, and I'd like you to try the your turn here. It says you throw a ball horizontally out of a window, so maybe here's the bottom of the window, and here's the ground below. If you throw the ball 5 meters per second, so horizontally, that means you're throwing it straight this way. So you're going to start off with Vx is going to be equal to 5 meters per second, and you're going to get that same kind of parabolic motion here. So it's going to come down this way. And the window is 4 meters above the ground, so in other words, this is 4 meters. How far away does it land? So again here we're going to be solving for delta x. So I've kind of started you off a little bit. Once you hit pause now, give that a try and see how it goes. Alright, I've got an answer here for you. Hope it worked out okay. So the first thing is I made sure I made that I indicated which way is positive for both my x and my y values. I decided to make down positive for y again, so that I got these are my y and my x. Again, I used equation number 1. It works out to the time is 0.894 seconds, and so I plug that time in the x side, and then when I solve for delta x, I got 4.5 meters. So I hope that went okay for you. Here, I'll just zoom out so you can see the whole thing. Here, moving on to example number 2, it says, at an accident scene, a car has driven off a 20-meter cliff and crashed 53.6 meters beyond it horizontally. Well, what would this look like? Let's see. So we've got a kind of a cliff here. I'm thinking maybe there's water underneath, and there's this car that was driving along and going at some speed. So this is what we don't know. It was going off this speed, and then it kind of veers off into the water and it crashes somewhere. We know that this height is 20 meters right here, and this over here they tell us is 53.6 meters. So there's a little diagram to help us out. I'm going to start off again. I'm thinking, because all the motion is downwards, I'm going to say that, in my x direction to the right is positive, and in my y direction I'm going to make down positive. So let's figure out all the stuff that we know. So in my x direction, I've got Vx is what I want to find out, and this would be my delta x, 53.6 meters. The time I don't know, So I really want to find that out, and I'll have to be using the y information to find out the time before I bring it over. My VI is going to be equal to 0 because it's taking off horizontally. VF, I don't know. My A is going to be positive 10 because I said down was positive. And I want to figure out what the time is. And what else do I know? I know that delta Y is equal to 20 meters. So it's really about how long does it take something to fall 20 meters. So the same idea, if I just drop something and it fell 20 meters, how much time would that take? It didn't matter if it's moving horizontally at the same time, it's going to take the same amount of time to fall. So again, I'm going to be using equation number 1, using the y information. Very similar. This first term is still 0 because the initial velocity was 0. So I'm going to say 20 is equal to 5 times delta t squared. Well, this will work out nicely because 20 divided by 5 is 4. So if 4 is equal to delta t squared, I'm going to say that the time could be plus or minus 2, but here it has to be positive 2 seconds. So I'm going to say it's 2 seconds. So here is also 2 seconds. So finishing up, I don't have quite an amount of space here, so I'll find somewhere else, maybe on the bottom here. I'm going to say that Vx was going to be equal to delta x divided by delta t. So this is going to be 53.6 meters divided by 2 seconds, which gives me 26.8 meters per second. And I just noticed now they say, oh, we want that in kilometers per hour. So if we have 26.8 meters per second, I'll tell you the shorthand method is just to multiply by 3.6, but I'll very quickly show you why. So if we're going from meters to kilometers, I can say that 1 kilometer is the same thing as 1,000 meters. And how many seconds in an hour? 3,600 seconds per 1 hour. 1 hour. So my seconds cancel out, my meters cancel out, and so what happens is you multiply by 3,600 and you divide by 1,000, which is really the same thing. This whole thing here is just the same thing as saying multiply by 3.6, and when I do that I get 96.5 kilometers per hour. Okay, all right, so there's one last your turn. So why don't you hit pause now and see if you can give that a try. Oh, I'm going to just make a change here. It says a ball's thrown out from a window, and then here it says building. So I'm going to say window again here. And again, this should be window. Those should all be windows. Yeah, I think you can get this. So give it a shot. Alright, so here's my answer for that. What's different about this one is that they gave you the time, so you didn't have to figure out the time in the y column and bring it to the x or anything like that. So it's actually a little bit easier. So here's all the x information we started with. The horizontal velocity was 10, the time was 5, so right away you could plug that in and figure out that this horizontal distance would be 50 meters. Similarly, you got all enough y information, right away you can plug it into equation number 1 and get the fact that it will drop 125 meters. Alright, so hopefully that went well, and just a reminder that there is a worksheet that accompanies this. Hopefully it's the next page of your package, and as always I will see you in class.